think we're going to start now. Good morning, fellow IT workers, to our presentation from a lot of boxes to a lot of words. It's about migrating to Xtext. We have more focus on the organizational impact of such a migration. Also have a glimpse on the technical side, but it's more about the organizational efforts that we have to take. I'm Jochen Schmich. I'm a software developer with Fiducia GAD IT AG. I have to pronounce it in German. It's better that way. Okay.
Yeah, my name is Henrik Bunder. I'm with Itimus as an IT consultant, and I work together with Jochen on this project, mainly focusing on migrating to Xtext.
Okay. So to the agenda, first off, we'll give you an introduction about to give you some context about the project and the company, and then we'll look at our ideas and our goals that went into the development of the Xtext tools. And the most important part will be how we're getting there, how we want to get to using our new tools. And finally, we'll wrap it up and give you some final thoughts. So first off, our company is a full-service IT provider for banks in Germany, for the Volksbanken, Raiffeisenbanken. I'm based in Karlsruhe, which is here, quite close to this location. We have 4,500 employees, of which thousands are developers. We also have some consultants in the house. Our main customers are 1,000 cooperative banks, as I said, the Volksbanken, Raiffeisenbanken, and other customers in other markets. Our main software, our flagship software, is Xtext-21. It's central banking software for the everyday use for the bankers. And yeah, some important numbers. The first version was shipped in 2003. And it's maintained since then. It has a COBOL portion which is run on the mainframe, and a large Java portion which consists of 97 million lines of Java code, including documentation and line feeds and so on. Important for our project is that Xtext-21 is made up of modules, and the code in these Java modules is generated from UML class models. Currently, we use IBM RSA Software Architect for this matter. And we have about 620 modules with generated code. These modules are relevant to our migration effort now. 105 people are responsible for these modules. They are responsible for maintaining the modules, for extending them. And of course, there are several other developers around writing code for these modules. And in our project, we have to deal with several restrictions. So first off, we have a restriction in budget and resources. So the project, creating an Xtext DSL and migrating from there, is done by, yes, for some months, 2 persons. Most of the time, a single person, which is me. And the second person is Hendrik. So that's a budget and resources restriction. Projects or module owners don't have overall freedom to do tool migrations and framework migrations. They have other things to do, so they have maintenance budget, but we're really restricted and limited in this area. So we have to do our best to avoid test efforts. So by avoiding test efforts, I mean if we migrate our models, we have to avoid code changes. So we have to avoid changes in the productive code. And we are also facing the fact that we have a great variety of model quality, which means not every model does fit perfectly to the generated code. That's another important point for us. So to the models themselves, they are pretty straightforward, pretty boring, framework-centric modeling, very technically oriented. They're all about our framework, the Java-based banking framework, JBF. They contain concepts like the application models, which are pochos on steroids or worse. They're mainly done for or used for interaction with swing user interfaces. We have services where the business logic is encapsulated. Those are modeled. We have enumerations. They pretty much resemble the EMF enumerations. And we have persistence modeling, well, configuration on how an application model is mapped to a database table and how our properties map to columns and so on. These are the informations that go into the models. So we have to transition these information from the old models to the new models, but before we can do this, and we wouldn't stand here and talk about migration if we wouldn't think about how to get there, how to make a good tool. So we first defined how our goals and our ideas, which went into the development of the Xtext-based tools. So how to make the users happy. First off, we wanted to give them a familiar language they can understand, and familiar concepts to work with, which first of all means we have to define a simple meta model, as straightforward as possible. Try to resemble framework concepts. Framework concepts are, like I mentioned, application model services. People know what they're about, how to work with them. I mean, the first version was shipped in 2003. They're pretty familiar to these concepts. And we try to make our meta model resemble the framework concepts as much as possible, like naming keywords like the framework concepts and so on. Remove unnecessary abstractions from the UML model, which we don't need anymore. Try to leverage the out-of-the-box features from Xtext because people are familiar with them, are familiar with working with code. So if you use a UML modeling tool, you always enter a new world as a developer. Many aspects are different, like when it comes to comparing and merging. We have a lot of different branches in the year, a lot of concurrent releases they have to handle, and when it comes to modeling and comparing and merging model, that's sure a hindrance for developers right now. And Xtext solves this out of the box and also comes with content assist and so on, templates. People are familiar with these concepts, and it's pretty intuitive for them to use it. We already had 2 Xtext DSLs for them to use and for some years. So we could gain experience with it, and the concepts that we used there also went into the design of the new languages, so people didn't find anything unfamiliar. Okay, also one important aspect for us when using Xtext was that with Xbase we were able to use JVM type references. So in UML models, if you reference types like string, integer, and so on, you probably go there and define a model library for people to use the types out of. Or if they reference types from other modules, they always have to check out the other models, the other UML models, or they introduce proxy types or something that is gone, that is just vanished. If we use Java types and make the generator understand that properly. And we also try to provide guidance for typical usage scenarios with quick fixes and validations to guide the user with a new language. So other than that, second important was fast results, have fast results for them in critical use cases like content assistance should happen really fast, also in large models, make generators work fast. in Rational Software Architect, we had generators implemented with the old open architecture well languages, expand and extend, and they were nice, but as interpreted languages, they are way too slow for this usage scenario, so we had to implement all generators with extend. And where this wasn't enough, we did some intensive profiling after we reached a certain maturity level of the tool. And we found other areas where we could solve performance problems with caching, for example, like had to carefully choose the points. But we reached significant performance improvements by caching JDT type resolution or index queries, for example. Well, another point which is very obvious is one tool to use now. Formerly, people would model and generate with Rational Software Architect and then switch over and carry on implementing in Eclipse. That is gone now. Also gone is the need to install Rational Software Architect, to maintain it, to train, to support it. That's, yes, another thing that's just vanished now, or will be vanishing after we finish migration. Well, one important aspect is visualization. People ask for it very often because models tend to get large, maybe not large in a technical sense, but if they have about 3,000 top-level elements like services, like classes, and so on, it gets hard for the users to maintain an overview, to get the big picture of the overall structure, and they need some means to get a big picture. And we used Sirius to create a simple class diagram. It was a matter of days to get that done, and it's the way you can work with it pretty much resembles the way you work with diagrams in Rational Software Architect. So people like that a lot. We added some filters and custom creation wizards to create diagrams easily, but that solved the problem really fast. So we also wanted people to have an easy transition to the new tool. Like we provided some good documentation, a comprehensive keyword reference, and examples. Well, after they migrate, they have files full of examples because all the existing model contents will be in there, and an ever-growing FAQ. So what do you get? It's pretty, it's not so exciting from a technical standpoint. It's pretty straightforward. You get two DSLs. It's the services DSL, which is about complex data types, services, enumerations, and some other bells and whistles. And the JBF persistence DSL, which is used to annotate the complex data types with metadata like how to map a certain class to a table, how to map a certain property to a column, how to map inheritance structures to tables, and so on. We also added the diagram support. As you can see here, it almost looks like a simple UML class diagram, which makes which makes it easy for users to adopt it and to use it. We also are a heavy user of Expect. We like that a lot. We have several thousand Expect tests. We also tested our migration tooling with that. And it will help us in maintaining the plugins in the future, of course. So now the next point.
I take over. Would you mind giving me the microphone?
Of course. Yeah.
Thank you. So more or less the point where I joined the project was when we had a huge part of the DSL was already defined and we had the new tooling, but we still were facing this situation. So we have like 620 existing components, as you can see on the left-hand side. And on the right-hand side, there's us with the new DSL, with the new tooling, maybe 1 or 2 projects created from scratch who can directly start with this new approach, but still we have to get all those boxes from the left-hand side to the right-hand side. And as you can imagine, and as it is intended to be to say by the question marks is that we don't really know what's in these boxes. So we know there are UML-based models. We know they do, or they have framework-centric code, but we do not know every nuances that there might be. So every component might look a little bit different, although they in the end are all UML-based and all generated code, which is according to the JBF framework. So just by saying, okay, we want to migrate from UML to DSL, you can say, well, that's an easy thing. Take the models, do a model transformation, and then you're done. Well, as I said, there might be some nuances between the model and the generated code, and maybe it's generated last time 5 years ago, so it's with a different generator version, and you're not really sure how the model is represented in the actual code. So you cannot really be sure that when you just take the models, you end up with the same, and that was one of the main prerequisites, with the same code that has to be run in production afterwards. So you want to keep differences really, really small. So what we did, we decided to do a reverse engineering approach. So instead of taking the models, we take the existing Java code and try to reverse engineer those components on the left to the right-hand side and bring them to the new tooling. So question is, how do we do reverse engineering? Well, the task at hand is easy on the first side. So if you take a look, we have Java files, and we have to get them to our DSL. But as you can imagine, there's no easy, direct way. So we tried to do it more structured, and we heavily used tools that are available in Eclipse. So first we started to utilize the Eclipse JDT to read those Java artifacts and come up with a Java AST, which represents the source code. And then the next thing, and that is the one where we put the most effort in, is the little green box down here, which is the DSL migrator. That is a piece of Xtend and Java code. Well, not a piece, it's actually getting large by time, but it does the migration from the Java AST over to the DSL AST. That works pretty well because we're reassembling framework concepts here and keywords from the framework, so we're quite close to the framework in our modeling, so we can do this migration easily, let's say. And then we're almost there. The last step, we again utilized something that is already existing. We took the DSL serializer, which we get from Xtext. We just pass it over the AST, and then we say, okay, please persist, and we get a nice DSL file formatted, everything's fine. If you haven't tried this approach to create a DSL AST yourself and then put it to the serializer, it's interesting because it shows you a lot of places in your DSL where you might not be unambiguous, and so it's really good way of quality, or to get quality in your DSL as well. So what do? We now have our migration tooling, we put it in the box, and we hand it over to our existing tools, and we just tell the module owner, well, here's the tooling, you know your boxes best, you know best your schedule, so just go ahead and please migrate from the right to the left. We call this approach shot in the dark. So we just sit on the right-hand side in our new cool environment, and we just rub the wonder lamp and wait for the projects to come over one by one, and we just wait and we welcome them, we maybe give them something, and at a certain point all of them are on our side, and we can just remove the existing UML tooling. We remove RSA, license costs, installation, extra support, and all that, and we're all in Wonderland. And that's how the migration worked. Well, you might figure it doesn't. Of course, this would be really nice if it works like that, but there are tons of problems that you will face when you try it this way. So first of all, there will be performance issues because some of these components will have a constellation that you haven't thought of, or that is so complex that your DSL is maybe not capable of handling it. You will have unexpected generator bugs. So there is some constellation that is only in 1 out of 620 boxes who just brings your generator to explode. Then it's unpredictable because you cannot say to the components, well, dear module owner, if you want to do your migration, please think about maybe 2 days or maybe 20 days to do that. You cannot tell for sure. You can tell it will take effort to get from the left to the right, but you cannot say it precisely. Then there is no governance. So how do we find out if all the models are really migrated, or are there any left? How do we get a feeling for that? Finally, there's no guidance for the users, so you just give them another tooling and ask them to do the migration on their own. And then, of course, as we said, we're limited in budget, and this Wonderlamp is definitely beyond our budget. So what we did is we took a step back and thought about who is actually involved in this process. And there are three main roles that we identified. The first is the tool developer, which is mainly us. And we have to develop the migration tooling as well as the DSL. And what we want to know is the generator working in all cases, and is the migration working? And are there any bugs or unexpected differences? And of course, as we said before, we want to have happy users, because that's important for the success of the whole approach. The second role that is involved is the migrator. The migrator is a role that is in charge of preparing and performing the migration for all the 620 modules, because you need someone who has a complete overview. What he wants definitely is, for 620 modules, you don't want to do that by hand, so he wants an automated process, and again, he wants to be able to tell the module owners what the effort will be. So he needs some sort of feeling, how many differences will there be, and how can how costly are they to bring them, to remove them. And finally, the tool users on the right-hand side, they have to review, test, and check in the code that we generated from the migrated model. So they have to be familiar with what they see, and they also want to know, are there differences? So with this in mind, we came up with a little different approach on which Jochen will evaluate or elaborate a little bit more now. So again, microphone for you.
Okay, thank you. Okay, thank you. Okay, if we pick out some certain points here on the slide, we'll see that some points are more different than others, or are different than others. They stand out a bit. You can't reach it, or you can't solve it by a classic approach, by just giving them a migration tool. This won't work, as we said. So if you look at, I want to know if the generator works for all modules. I want to estimate the effort for all modules or for certain modules. And he wants to know the effort to tell it to his project manager. So I think we don't need only a magic lamp, but also a glass bowl where we can look in the future. So we don't have anything like this. So we needed to augment or enhance the migration process. So we already have our reverse engineering tooling, and we embedded it in a larger context or in a larger process, where we check out all the modules every night in a Jenkins job, all the code, compile it. We work with JVM type references, as we said. We need to compile it. Then run the reverse engineering tooling over it, extract the DSL AST, serialize it, run the generator, and collect the metrics that we need. So the metrics that we need is, for example, the differences that appear. As I said, we need to avoid code changes. So we compare the generated code that is generated from the migrated DSL with the existing generated code, and we collect these changes and also categorize them. We categorize them by telling structural changes from textual changes, from Javadoc changes. Structural changes are the ones that are really critical to a developer, because they are relevant to the compiler, which means testing efforts. And we also collect some metrics, like the runtime of the migration, how long did it take, like errors that occurred throughout the process, like numbers of model elements that were extracted from the source code. And we all write them out to several output formats. First off, we collect all the code changes in a huge zip file, where you can review each and every project on how much changed code is in there, and with all the categories, of course. And we also generate a website with all the metrics that we collected, so we can review them. And we also generate, as another output format, is a CSV file for making quick pivot tables in Excel, for example. So let's have a closer look at the website that we generate. From here, we can satisfy every role that is involved. First off, we have several information items on there. First off, how many projects are involved, how are they called, what are they called, who is the owner, who is responsible, how many elements are in there, how many structural differences, and so on and so on. There's a detailed view also. Now, the migrator is foremost interested in who's owning the project, who is responsible for the module, because he wants to use it as a grouping criterion. He wants to make a plan. It's better to get to a module owner that owns 50 projects, because he can migrate them all in a row, and he has to explain it once to the person. It's better than to step to a module owner that only owns 2 modules, because it would be a certain overhead involved. So next numbers he's interested in is the element count, how many top-level elements are in there, and how many structural differences are in there. So from it you can tell the gain and the complexity. So if you, I don't know if you can read it, project 100 contains 1,200 elements, which is good, it's quite much, and it only has 4 structural differences that are really relevant to the compiler. So it has not much complexity, but a high gain. Many elements are migrated, so it's better for the overall progress of the migration to take that first. Okay, next guy who's interested is the tool user or the module owner, because he wants to know how many code changes the migration will cause. And he gets the answer and he can tell it to his project manager, so he can plan on when the migration should happen, or if it should happen within the next release cycle, something. And then it's us, the tool developers. From the detail view, we can see how long the migration took. It's a performance question. Also, the count is important for us in a technical sense, also important for performance, optimizing a tool for a special number of elements that it has to able to support. And also the differences in total. If we improve the migration tools, if we improve the generators, it might mean less differences, less code changes, easier migrations, faster migrations. Also, we're interested in exceptions that have happened throughout the process, or if any errors occur on the model, on the newly generated model. So we can optimize in advance before we start a migration, so users can start right away. And yes, one thing people love is that we collect all the code changes in a huge zip file, so they can have a look at just the things that they interested. So they can look at the code changes only without any white space changes or Java doc changes. If you went through a series of files, like 100 files, and you have to check each and one for code changes, and every file, 99 files only contain white space changes, and 1 file contains really relevant change, then it would be better to provide such a tool. People like it a lot. So let's wrap it up.
Okay, so final thoughts on what we did. So it's just switching a lot anyway. So what we found, first of all, what I want to highlight is a little bit the lessons learned. So what did we learn on the way? First of all, Xtext is really, really useful to back those domain-specific language approach, Xtext approach, with a sophisticated set of tests. You just sometimes need some patience to get it completely running. But once it's there, it's really helpful and often really gives us a good feedback when we change something. The Eclipse compare mechanism we found, that was the one we were thinking of when it comes to comparing the differences, because it's actually quite nice in Eclipse already, but it's very close to the UI, so very closely coupled as we found. So it was not possible for us to use it on the Jenkins CI where we were running this migration job. We also found that JDT indexing sometimes is a point where you can improve performance easily, and we're really looking forward to the new implementation because we think there might be something in it for us that we can improve or that we can remove a little bit of code from our base to go to a more standardized way of how the indexing is done. For the diagram support, you always have to switch in a specific perspective. That's something where we found, okay, that might be nice to do that from the package explorer as well. But we haven't had the time to work on that on our own or to go a little bit deeper into that. The one thing that is most important for the whole migration approach and the expected influence on the whole organization is that we have to test with real modules to give a comprehensive forecast. So you can only tell if the migration is working for a specific project if you have done some kind of dry run to be really sure. And finally, the point that helped us a lot is, in the end, the Eclipse ecosystem, because we get a lot for free, not only JDT, but the Xtext serializer and also all the view support and all that stuff really helped us to focus on our main goal, which was creating a DSL and migrating to that DSL. And that was something that was really well supported by the Eclipse ecosystem. And now from a more project point of view, Jochen will give some more insight.
Okay.
Final switch between the two of us.
Okay. Yes, from a user point of view, we received very positive feedback because the tool was very stable. We had not so many bugs. Yes, because we could analyze it in advance. We could predict on how good it would work for each user. And each of the boxes had its own specialities. It was each box that you saw, as of now, was very special. Each one had a new thing that we stumbled upon. So it was quite good to see it in advance. The languages are very developer oriented. So Xtext provides great support here to write good tools. We got to say that for the 1000th time, I think. Projects only needed very minimal effort for migration. Some weeks ago, I migrated a batch of 30 projects, and the module owners only needed about 3 hours to integrate it with a production stream to check it in, and that was not much compared to other model migrations. Training included, and getting used to it. Okay. And review included, of course. We needed virtually no training because all the models were there, all the examples were there after the migration. So they could jumpstart right into their work. They didn't need any more training. We also improved model quality because before models and code could vary. There was a slight gap could be between them, and now this is gone after the migration. And we could also leverage the benefits of textual and graphical modeling because also Sirius is a very good tool, very easy to get things done in a short matter of time. And yes, we'll use this automated migration environment for future use, for impact analysis. For example, if we change the generator in a certain way, how would this impact the existing code base? Okay, we're done. Thank you. Do you have any? Do you have any questions?
What you're migrating doesn't map one-to-one to the DSL or for whatever reason.
Yeah.
How do you approach that? Do you extend your the migration, it doesn't map one-to-one, but maybe we can maps to like this construct, and you can replace one node from original AST with the collection of nodes in the DSL AST, so it like preserves behavior? Or do you change the thing you're migrating to map to work better with the target DSL? Where would you?
Okay, this depends. Yes, I think your question was how we react to gaps in the DSL. Yes. Okay. Yeah, it depends. It depends on how many people face this gap, and depends on how hard it would be, how hard it would hit them if they had to change their code. So yes, we've encountered several of these gaps. And in some cases, we fixed them in the DSL, enhanced the DSL, or we added some text files next to the DSL that enhance the generator, and the generator knows them, and it's kind of a workaround. Or we could get a module owner to fix the problem in the code, which was the best way to do. Okay. Carsten?
I was surprised by the size of your project. I know that's a big application, but 90 million lines of code. The whole Eclipse restring has 17 million lines of code. So your single project is bigger than whole Eclipse.
No, not our project. I mean the Xtext software.
Yeah, the software.
Yes, but there are several numbers around. This is the one including comments and line feeds and so on. Only statements, it's way lower. Yes, but it's still very big, yeah.
And what, how large is the code base that a usual developer works on in this workspace?
This also depends from like 10,000 classes to, yes, much less, yes. Yeah, it depends very heavily. Varies with every module. You have huge modules with tens of thousands of classes, and you have smaller modules with only like 100 classes, 50 classes or something, if you take classes as a metric. Yeah?
One more from me. So my first question was about the issues you detect during the migration. Okay, there is a concept we don't support, or it throws exception when something happens.
Yes.
What about things that are not detected this way? Like every migration goes through and it looks fine. Then
Yes.
how do you know that we didn't change in the end to runtime behavior, or in general the semantics? Like, do you, like, besides manually someone doing code review on the migration, which can be maybe a lot of code to look at?
Yes.
So do you then afterwards, from the migrated DSL, generate the Java implementation or some implementation, and then run the test from the original project against that implementation? Or how do you approach to know that you didn't change the model in a way that now it's doing something else? The project after migration is doing
Okay.
something else.
Yeah, well, first off, we tested generators, and we'll test our reverse engineering tool with the generator tests, so we can figure out in the first place if we did something wrong, and well, the other things are tackled by the review process afterwards. The migrator role will review the code, will check out the structural changes, and then the project, the module owner will check out the structural changes, and I think...
So it's a code review?
Yes, basically yes, it's code review, yeah. Okay, I think we're overdue, so okay. One last question.
Okay, so my question is that how do you know that there is no information lost from the original model during reverse engineering?
Yes.
Because it's a design document, it contains many other things that do not appear in the source code. So if you reverse engineer, you create something equivalent to the source code in terms of structure and information.
Yes. Well, we're in the lucky situation that most details really actually were in the source code, So that's good, one good thing. And the other thing we could use for reverse engineering were other files. For example, we had a intermediate model which we used, which was generated throughout the generation process from Rational Software Architect. And we could also reuse this one to fill out some gaps that we encountered. So,
we were
but
actively going for removing abstraction that we no longer need, so that things that you might be in a platform independent model or something that was turned into platform specific. This classical MDA approach, and actually the one that was really interesting was the platform specific model, which was in the end close to the code, and in combination with intermediate models we could preserve the information that we needed for this approach without losing anything that is important.
yes.
Okay. So then again, thank you.
Okay, thank you.
Thank you.